Assalamualaikum and very good afternoon to everyone. Welcome to our presentation. So firstly, I would like to thank you to our panel for giving this opportunity. So today we will present to you the temperature average detection system. Okay. Um, Let me introduce myself first. My name is Lukman Hakim bin Muhammad Yedin and my partner is Muhammad Anwar Afif bin Ismail. Our group consists of two members. Next. So today we have four content. So I will present to you which is introduction, block diagram and conclusion. Coding and result we pass to my partner, Nafif. So for the introduction, our group project regarding a method for leveraging LCD display to determine temperature average. This application explains how to use the STM32 to construct a straightforward application for temperature measurement. So before we start, what is temperature sensor? The temperature sensor is integrated in the STM32 microcontroller, which is provide an analog output voltage proportional to the chip junction temperature of the device. The temperature information provided by sensor is the thermal chip junction temperature, actual temperature of semiconductor surface, and may differ from the ambient temperature. So for the process flow, the temperature is internal connected to the channel A, ADC1 of the ADC, which is ADC means analog to digital converter in STM32, and it's used to sample and convert the temperature sensor output voltage. The raw ADC data must be further processed to display the temperature in standardized unit measurement, like Celsius, Fahrenheit, and Kelvin. The ADC reference voltage VDDA equal to VREF is connected to the 5 volt VDD power supply of the STM32. If the VDD value is not accurate, it must be measured to obtain the correct overall ADC conversion range. Okay, move to the block diagram. So our group using 3 temperature sensor which is connected to the STM32 and the data is shown on the LCD. If the average temperature is higher than temperature 2, LED will illuminate. Okay, I will move to the next part, flowchart. So for the input, we have 3 input, temperature 1, temperature 2 and temperature 3. So after the input, we move to the process, collect 3 data of temperature sensor. So the next process is to calculate the average of 3 temperature. After we done the calculation, output will display data and average on LCD. Before that, we have a selection. If average is greater than temperature 2, LED will turn on. And if not, the temperature sensor will collect the data again. So I will pass to my friend, the next presenter.
Okay, I will demonstrate the simulation first. So as you can see here, the LCD is displaying all the same value, which is from the temperature one. Well, that is our problem. We only can detect the temperature one value to be displayed on our LCD, and we can uh, get the true method to the face the other two temperature sensor. So the temperature one is showing 29 degree, so that the LCD will display that value. So if we change the temperature will uh, change accordingly uh, to the temperature sensor one, and the average will show temperature one also, because there is no other temperature to be compared and to be added as the average temperature. So that is our problem. We show in details in the coding. So at first, this is the part where we declaring variables, and this is the part where we sending commands to display the uh, what what are the string that we need to display on the LCD. And this is for the clock initialization for ADC1, GPIOA, and GPIOB. So for this clock initialization for ADC1 is 002, and for GPIOA and GPIOB is 000C. So we combine those two, we get 0 to 0C. And this is for uh, GPIOA and GPIOB configuration, pin configuration. So PF5 and PF7 is set as output, which is for RS and EN. And for PF1, PF2, and PF3, we set them as analog input, which is only 0. And this is for the output, which is for the LCD. The other one from 0 to 7, and this is for the LED that's supposed to illuminate when the temperature uh, when the average is greater than temperature 2. And this is for the ADC initialization, and this is for LCD initialization. This is where we send the commands to display the string from this on the LCD, which is this is for A, B, C, and D. Okay, this is uh, where we start to uh, fetch the data from the temperature. This is where we start conversion on regular channel, which is channel 1, and this is for monitor AOC bit in the status register. The temperature value need to be split into two part, which is quotient and remainder, as the ASCII code need as from analog to digital, we need to convert the value uh, to ASCII code, and ASCII code need us to split them into two. So we split them into quotient and remainder. For quotient, we divide the value by 10, and for remainder, we modulate it by with 10. So after that, after we get the value for this group, we add them with 0 times by 30, because To convert them to ASCII code, we need to add this value. ASCII code is start with 30, and for the rest of from this part to this part is actually for temperature 2. This is for temperature 2, this part, and then for this part, this is for temperature 3. But because of we don't know what is expected to fetch the data, sorry, I mean to change, to send command to change, to read input from temperature 1 and temperature 2 and then temperature 3. So we can operate, we cannot operate this command, this coding, this part of coding. So for the temperature 1, this display we use this, which is we start from position 6 at line 1, and for temperature 2 we start at position 6 at line 2, which is TC6, and for temperature 3 we start at position 14 at input, which is AED. And this is for the calculation for the average temperature, which is a simple mathematics, and this is for displaying the average temperature, which is the same method that we use. We need to split the value into two, and this is the condition to turn on the LED. This is where we display the average. So if we get to know to fetch the data from temperature 2 and temperature 3, the LCD is supposed to display the value of those two and the calculation of the average. And the rest of the coding is this is for reset RS pin to 0 and set only EN pin to 1, RS still 0, reset only EN pin to 0, same as this for LCD data, which only this part is different from before, which we reset RS pin into 1, and the rest is the same as the previous part. Okay, for the discussion, for this project, we use temperature sensor to detect temperature and display it into the LCD. Basically, we use 3 temperature sensors to determine the average of temperature. For frequency of STM32, we use 36 megahertz throughout this project. In order to transmit the temperature value from LM35 to the LCD, we need to do analog to digital conversion. That is why we use ADC1 mode in this project. The value from LM35 need to be converted into ASCII code. To be able to do that, we need to separate the temperature value into two, which are quotient and remainder, then add them with 0 times by 30. Okay, for the next part is conclusion. I will pass to my group members.
For the last part is conclusion. In conclusion, we'll be able to transmit the data from temperature sensor to LCD by using STM32. However, we were unable to interface the other two temperature sensor to the microcontroller as the data display for temperature 2 and temperature 3. On LCD, we actually data from temperature 1. Average temperature only display the value of the temperature 1 as there is the only one temperature data being transmitted. That's all from us. Thank you.